2.5 measures of central tendency. So central tendency, when we talk about central tendency, we can talk about the mean, median, modes, and outliers. So what is the mean? Mean, if you sum the values that you have, the data, and divide it by the number of the data, it's going to be mean. It's kind of average of your data. If you're taking the mean of the population, you show it with the mu, this symbol. And the mean for a sample is going to be X bar. So what is the median? Median is the middle number. If you rearrange your data from the lowest to the highest, the middle value is your median. What is the mode? The mode is the data that occurred most frequently in your distribution. And outliers is numbers that are very far from the majority of the data. So the outliers coming in next lesson. Okay, looking at this question, 2 classes that wrote the same physics examination had the following results. Class A here, class B, that's the result. Determine mean, median, and mode. So for mean is easy, just add all of this data you see here and divide by number. If you count them, you see we have 17 of this data. So 71, 82, 55, until the last one, which is 68. You do it, you have 17 of that, divided by 17, that would be 71.5. That would be the mean of class A. For class B, you do the same thing. You add all of the data, so we have 18 of them. You count it, we have 18 of them. Therefore, it would be 71, right? For the class B. To find the median, we have to rearrange it. For class A, we rearrange it from the lowest to the highest. If you look, the lowest number is 51. I'm gonna put 51 here. Actually, the lowest is 45. 45 is there. Then let's see if do we have anything else. Then 51, then 55. After 50, we don't have any other 50. Going to 60 is 66 here and 64 and 68. So 64 first, 64, then 66, then 68. We go to 70. So the lower one is 71. We have another 7. Actually, we have 70 here. Let me just write that 70. The 70. We have another 71 here. Then we have, okay, we have 73. We have 76, right? Here, 76. We have we're going to 80. Oh, I didn't. We have 371. Let me just write another here. I'm going to make more space. We have 371, 71, 71, and another 71. Maybe I just put a comma. Make sure there are different numbers. Yeah, 71, and then we go to 80. So you have 82, here is 84, 83. So start with 82, there, 83, 84, and then 90, then 95. So we rearrange it from the smallest to biggest. Now we want to find a middle number, right? Totally. Okay, I'm gonna teach you a method that you remember how to find a middle number. So we have 17 data. Look, if you have 3 data, like 1, 2, 3, and you wanna find the middle number. So what you do, so since you have 3, you say 3 plus 1 divided by 2. So it's gonna be 2. Your second data will be your median. So the same thing, I have 17 data, which is odd, right? Like 3, I have 3 data here. 17 plus 1 divided by 2 is 18. Divided by 2 is 9, right? So the 9th data here is going to be my median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 71 will be my median here. I'm going to just check the answer. Here is for A. I have 69 here. Okay. So for class A is 71. So I'm gonna do the same thing for the second class. Let me just erase this. So from the lowest to highest, I'm gonna rank it. So just give me a minute to do this, and to rearrange the class B from the lowest to the highest, as you see here. Since we have 18 of that, I'm gonna give you an example. Like if you have 1, 2, 3, 4, what is the middle one? We don't have any middle. Because these 2 will be my middle, right? The second and the third data. You know, when you have these 2 middle, you just add them divided by 2 to get the middle data. So how do you know which data? If you have a lot of data, how do I do it? So this is the method. I have 4 data, right? 4 plus 1 divided by 2. 4 plus 1 is 5 divided by 2 is 2.5. 2.5 is a number between 2 and 3, right? That's why my second and third data will be my middle data. So I'm gonna do the same thing here. So I have 18 data. Here I have 18 data, 18 plus 1 divided by 2. It's gonna be 9.5. 9.5 is between 9 and 10. So the 9th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, and here is 10. 69 and 70. I take these two. So what do? You just add them divided by 2. 73 divided by 2. That would be your median. It's calculated using calculator. I'm gonna just quickly check here. No, 69 plus 73 here. So it's gonna be 71. So your median here will be 71. For previous one, the median also was 71 as well. Now, how about the mode? We're looking back at the first one. I know for the first one, let me just erase this. But for first one, it seems that 71 occurred 3 times, right? The mode is the number that occurring more frequently. So the mode for class A is 71, it's occurred more frequently. And here, I believe that was 80 that happened twice. Let's just check. There are two most things, the value 61 and 80 was occurred twice. So 61 and 80. So here is 80 here and 82 times. Here is 61 and 61 2 times. So 80 and 61 will be the mode. Now part C, what is the effect of any outliers on the mean and median? So look, we have 12, it's very far from the bulk of your data. Yeah, so of course it will really shift your median. Closer examination of the few data shows that aside from the two extremely low values of 15 and 12, in class B, the distribution are not all that different. Without these two outliers, the mean of the class will be 70.1. Almost the same as the mean for class A, because the relatively small size of class B affect the outliers on its mean is significant. However, the values of these outliers have no effect on the median for class B. Even if the two outlier marks were changed to numbers in the 60s, the median mark wouldn't change because it would still be greater than the 2 marks. Okay, so it's not gonna, if you just remove 12 and 15, it will not change the median of the class. So it's just 17.1, which should be close to the mean of the class A. So it's, okay, now let's see if we have a weighted mean. If we have weighted mean, the weighted means how frequently this data is happened. To find the mean value, just weight multiplied by the data plus the weight of the data multiplied by the data. So on divided by the addition of the weights. Okay, let's just do a question. The personal manager for Statville Marketing Limited consider 5 criteria when investigating a job applicant. The manager gives each applicant a score between 1 and 5 in each category, with 5 as the highest score. Each category has a weighting between 1 and 3. The following table lists a recent applicant scores, the company weighting factors. So here's the weighting factor. Okay, weighting factors is how important is the data for the education. See, the weighting factors for education is 2, for job experience is 2, for a scale for interpersonal skills 3, and communication is 3. Reference 1 means that interpersonal skill and communication skills is most important for the company. And after that, education and job experience is more important, but is the least important, right? So reference is not much important because the weighting factor is. If you want to find the mean value for this job, of course, say 4 multiplied by 2 plus 2 multiplied by 2 plus 5 multiplied by 3 plus 5 multiplied by 3 plus 4 multiplied by 1 is in numerator. And then you're adding your weights. Your weights added 2 plus 2 plus 3 plus 3 plus 1 would be in denominator. Then the mean score is 4.2. So if the unweighted mean is simply the sum. If you want to do unweighted, let's say that we don't have any weight for this scores. What do? Just simply add them divided by 1, 2, 3, 4, 5, right? All right, yeah, 5 of them, and it's going to be 4. So here, when the data has a grouped interval, you approximate the mean using this formula. F is the frequency of the data happening, M is your value, data value. Multiply them divided by addition of the frequencies. So let's just do an example here. Number of the hours A group of children were asked how many hours a day they spend watching television. The table is right. Summarize the responses. From 0 to 1, 1 child. From 1 to 2, 4, and 2 to 3, 7, and so on. To find the mean value, what do you need to find the midpoint between this range. So from 0 to 1, 0 plus 1 divided by 2 is 0.5. 1 plus 2 is 3, divided by 2 is 1.5. 2 plus 3 is 5, divided by 2 is 2.5. 3 plus 4 is 7. 7 divided by 2 is 3.5. So kind of you find the midpoint of each interval. Then that with my data, it is frequency of that happening. Then you multiply the frequency by the data, right? The midpoint by that. So 0.5 multiplied by 1 is 0.5. 1.5 multiplied by 4 is 6. 2.5 multiplied by 7, 17.5. 3.5 multiplied by 3 is 10.5, and so on. You find it. Cumulative frequency, of course, is the first one is stay the same. The second one is going to be 4 plus 1, which is 5. Third one is 7 plus 4 plus 1, 12. 3 plus 7 plus 4 plus 1 is 15. 2 plus 3 plus 7 plus 4 plus 1 is 17. 1 plus 2 plus 3 plus 7 plus 4 plus 1 is 18. This is cumulative frequency. Okay. So we have addition of all add all the frequencies here. We had add all of this frequency multiplied by midpoint is here. According to the formula, 49 divided by 18 would give you the mean values. Okay, for the practice, I'm asking to do question number 1. Question number 9 and question number 11.